So in the last video, we explained where the energy for a star comes from. It comes from nuclear fusion in the core and the conversion of a tiny bit of the hydrogen that's being fused into pure energy according to E equals mc squared from special relativity. The instant that that core fusion begins, that the temperature of the core hits that magic number of 10 million Kelvin. Now the core continues to shrink for a time, and we think the core of the sun is probably about 15 million Kelvin. But at 10 million Kelvin, nuclear fusion can begin, and when it begins, that is the instant that a star is born, that the protostar converts to what we now call a star. So the sun and other stars are giant balls of hydrogen that have contracted enough under the influence of gravity to heat their cores up, not the whole star, but the core hot enough to fuse hydrogen into helium, what we call core fusion. I hope there's no confusion about core fusion, but this is core fusion. Even over on online lessons, I have to make bad puns. But anyway, the sun and other stars are powered for most of their lives by fusing hydrogen into helium. Now, how much? Now, remember, we talked about the mass defect being only 0.7% of 4 hydrogen nuclei, 4 protons. Protons are really small. And 0.7% of really small is really small. Even converting that into pure energy doesn't give you a whole lot of energy. But the sun is huge. It's much bigger than we usually imagine it to be, because it's not a few protons that are fusing in the core. Every single second of the sun's life for the last 5 billion years, for another 5 billion years, it's been fusing 600 million tons of hydrogen into helium every single second. Snap your fingers. That's about a second. In the time it takes you to snap your fingers, the sun has fused 600 million tons of hydrogen to helium, another 600 million tons, another 600 million tons, another 600 million tons. And it's been doing that for 5 billion years, and it's still going strong. And 600 million tons of hydrogen produces a whole lot of energy, even though only 0.7% of that 600 million tons is converted to energy. How much? Well, it generates 3.78 times 10 to the 26 watts of power. That's a watt is a joule of energy per second. 3.78 times 10 to the 26 joules of energy every second. How much is that? That's this, compared to like a 40-watt light bulb. But to give you an idea of how much energy there is, Canada's annual power use as our entire country is about 10 to the 13 watts. Okay? That is a factor of 13 times less than what the sun produces in one single second. Okay? That's 10 trillion times less energy in the entire year. So if we could ever figure out how to collect all of that energy that the sun produces in 1 year, sorry, in 1 second, and we can't. If we ever tried collecting that much energy, whatever we use to collect it would vaporize instantly. But if we ever could, the sun produces enough energy to provide all of Canada's energy needs for 317,000 years. That's a lot of energy. Now, this flow of energy, other than just, providing us with heat and light, has another important consequence. Remember that this whole process began with the nebula shrinking down because of gravity. The gravity is still there. The gravity is still trying to pull all the matter of the sun or the star together. Why then isn't the sun shrinking? Why doesn't it keep shrinking? Why hasn't it shrunk to a tiny size in the last 5 billion years? Because it's being balanced, because the flow of energy outwards from core fusion carries electromagnetic force with it. And that electromagnetic force outwards from the core fusion balances the gravity pulling inwards, and the star becomes stable. This is a state we call hydrostatic equilibrium. Hydro refers to fluids, static means unchanging or constant, and equilibrium is a balance. So it's a balance, an unchanging balance of fluids. And from a physics perspective, a fluid is anything that flows, so it can be a liquid or a gas, or in the core of the sun, a plasma. So the star now exists in a state of hydrostatic equilibrium as a result of the fusion of hydrogen into helium in the core. In the next video, we'll see how the energy gets from the core of the sun to outer space and eventually onto the Earth.